Damn, math is just too damn hard. I don't get any of this.
Hello, Abhiram. Hello. They seem to be yelling. Is everything okay?
I don't get this thing called implicit differentiation.
Don't worry, that's pretty easy. We can teach you that real quick.
Wow.
Yeah, we got you. Let's go to the library. All right, Abhiram. It seems this is a question that you have struggled with, right?
Yeah.
So we're going to start off with this easy first derivative problem. What we're going to do is we're going to take the derivative of both of these sides with respect to x. And then dx. I'm just going to put it right here, but you know what I mean. So now, for this problem, it's a bit hard because you don't know what to do, but it's actually a product rule. So let's first split the terms. 3x squared and y. Derivative of y, dy dx. And then 3x squared, 6x. And now we just multiply this and this and add it to this and that. So we'll get 6xy plus 3x squared dy dx. Now let's handle this one. Similar situation where they're multiplying each other. So you're going to get minus y squared and x. Now that's negative 2y dy dx and 1. And now you multiply, boom, boom, and you get minus 2xy dy dx minus y squared. And now we have 5y. Now 5y is just 5 dy dx because of the y. So it's just plus 5 dy dx. And 10, since 10 is a constant, what do we do with it?
Derivative of constant is always 0.
Boom, beautiful. So it's 0. And now we want to isolate dy dx and put everything that isn't dy dx on one side. So first, let's handle this. This is the only thing that isn't with the dy dx. So
And the negative y squared.
And the negative y squared. Thank you for pointing that out. And we're going to move that all to one side. So we're going to get y squared minus 6xy equals 3x squared dy dx times 2xy All right, and now we're going to take out dy dx from this equation. So we're going to get dy dx minus 2xy plus 5 equals squared minus 6xy. And now, really simple, we'll just divide this by this, and we'll get dy dx is equal to y squared minus 6xy. 3x over 3x minus 2xy plus 5.
All right, I think I get it, but what about double derivatives?
Don't worry, I got you for that part.
Yeah, Akshaj, you got you.
All right, Abhiram, let me explain it to you. So you gotta take d dx of both sides. So this just becomes d squared y dx squared, and this becomes we gotta use product rule for this. So it's gonna be 4 y squared plus the derivative of y squared is 2y dy dx. We gotta multiply it by 4x, and then product rule here. So it's just gonna be dy dx times 2, and then this is just 2x. You got that so far?
Yeah.
All right. So now we have dy dx here, dy dx here. So what we do is we plug in what dy dx is originally, which is all this. We plug it into there. So d squared y dx squared is equal to 4y squared plus 2y, and then this is 4x y squared plus 2y minus x squared times 4x, and then plus 2 times all this again, because that's dy dx. 4x squared, 4x y squared plus 2y minus x squared, then minus 2. Alright, Abhiram, do you understand it now? Are we done yet? not even halfway done yet.
Okay, fine. What about horizontal and vertical tangents?
See, it's a good thing you call that, because I know just the guy. Uh-huh. Oh yeah. No. It's a code black. It's a code black. I'm talking zip sort levels, but bad.
Who'd you call?
My son. I called the math genius, Michael Zorpson.
All right. Who here struggling with horizontal and vertical tangents?
I am.
All right. Let's go. All right. So let's get started. So vertical tangent. So with vertical tangent, we want to see when dy over dx, or we want to see when the denominator is equal to 0. Now for horizontal, we want to see when dy dx, this is a upper numerator is equal to 0. So
Okay, I think I get it.
great. All right. So here's our equation, right? We're going to solve for vertical tangent, which, reminder, you need to make sure the denominator is equal to 0. So let's go. So what we're going to need to do, we're going to need to, honestly, I'm just going to find the derivative of this first. So 2x plus 2 plus 4y cubed dy over dx plus 4 dy dx is equal to 0, because derivative 5 is 0. So now let's just solve for this in terms of dy dx. So keep them on the same side and move the other numbers to the other side. So we're going to have negative 2x minus 2 and 4y cubed dy over dx plus 4 dy dx. So if I factor out the dy dx, so we're going to dy over dx is equal to 4, times 4y cubed plus 4 is equal to this. And what we're going to do, we're just going to divide it simply to isolate dy over dx. So that's going to be equal to negative 2x minus 2 over 4y cubed plus 4. So dy dx. So next, I'm going to go up here now, just because what we're going to need to do is we're going to need to set the denominator equal to 0. So we'll start with 0 is equal to 4y cubed plus 4. Basically, I'm going to solve. So negative 4y cubed, and divide by 4, so just 1, negative 1, so the y cubed, and yes, cube root of negative 1 is just going to be negative 1. So y is equal to negative 1. Pretty sure. So now that we have all of this information, we can go back to this equation and we can actually plug it in. So plug it in for, so x squared plus 2x plus negative 1 to the 4th plus 4 to the negative 1st equals 5. Basically what you're going to have here, x squared plus 2x plus, minus 1, my bad, and minus 4 is equal to 5. So now we just said it. Actually, we can just as you can see, we have sort of quadratic forming here. So what we could do here is move the 5 over here. So this is going to be negative. This is going to end up as negative 5. So it's actually just going to end up being x squared plus 2x minus 5. But we also subtract 5 from this side. It's going to be minus 10 is equal to 0. So here's the fun part. We all remember quadratics, right? So we're going to do here, find two numbers that equal to negative 10 and two numbers that add to 2. And what are those numbers?
It's 5 and...
Trick question. We can't. Oh my god, are you okay? I'm sorry.
Yeah, good. That was a really good throw, actually. Wait.
Yeah, so fun fact, I can't do this in my head either, so that's why I got a TI-84 CE. TI-84 CE. So we're gonna do here, what I have is an extra cool function. Here, come to my, so quad 1, and I can do the A. So the A is 1 because it's 1 times 2 times x squared. B, 2. C, -10. And boom. So numbers, -4.317 and 2.317. And these two numbers here are possibilities for what x could equal to be points of the horizontal tangent. And honestly, if we were to graph this on Desmos, we'd be able to see that there would be 2 vertical tangents at these two at the x coordinates, which
Horizontal. All right, you might be wondering why there's no question on the board. But that's because I'm gonna do it online. All right, now that we're online, we have a problem here, and we have to find the horizontal tangents of this. So first we differentiate it. We put ddx on both sides, so ddx of x squared plus y squared is equal to ddx of 25. So derivative of x squared is just 2x. Derivative of y squared is just 2y dy dx due to chain rule. And derivative of 25, derivative of any constant is just 0, so we get equal to 0. So now with this, we want to isolate dy dx. So dy dx is equal to negative 2x over 2y, which is equal to negative x over y. So for horizontal tangents, we have to find when our numerator is equal to 0. So we set negative x is equal to 0, so x is just equal to 0. And now we plug this back in to our original equation, and we get 0 squared plus y squared is equal to 25. So solving this, we get y is equal to plus or minus 5. That means we have horizontal tangents at 0, 5 and 0, -5. And done. Now that that's finished, I should go and thank Michael. Thank you so much for teaching me implicit integration. Oh my god, I understand now. Oh my goodness, thank you so much. I actually understand the concept.
Oh, hello? Oh, sorry, Abhiram. Some kid just called me. He needs help with finding cross sections with volume and stuff. So I'll be on my way. See you.
All right.